All right, let's do some experiments. I got it all set up. Let's get this going. Get this going. See what kind of vortex we get going here. Well, I got this. Do I have a... I didn't bring it, did I? Where's the other flask I have? Maybe I left that upstairs. Go get that real quick. My other flask. Okay, I did leave something upstairs in case we get to it. Let's pop this in here. Oh, all right. What's going on, Phoenix? Sorry, I was had to go get some extra experiments if we get to them. Voice, hello, Grayson, and Welpsy. Let's start just seeing what we got going on today. We'll drop a base in both. I think, oh, that's kind of pretty. We're getting some nice flow patterns over there on the left. I tend to see that with the smaller. Yeah, that's nice. With the smaller vortex. Oh, that's a beautiful rainbow effect, huh? Yeah, the left one's looking nice. Let's add like 3 drops over here on the right. Beautiful. Beautiful, beautiful. Looks like we've neutralized the flask, right? We got green color. We've got neutral over here on the right. Let's add a bit more base. See if we can get them both to violet. Sure enough, they're both a pH 10. They are both very basic. Now we'll add some acid and send it in the other direction. Over here in the United States, we are getting ready to celebrate Thanksgiving tomorrow. Why don't you drop in the chat some things you're thankful for? Oh, that's gorgeous. I'm thankful for that rainbow, baby. That's what I'm thankful for. That's beautiful. What are we thankful for today? It's pretty. I guess folks are shy, huh? Somebody's thankful for change. They went from Tennessee to Germany, chartreuse. Okay, that's what I'm seeing. A little bit of a change in your life. That can be good. That's right, chartreuse. My sister is indeed from Tennessee. You remembered. Yep, you certainly, we must have. We must have. Oh, that's gorgeous. Phoenix is thankful for friends and family that love her. Or them. I'm sorry, I shouldn't assume. Yeah. Me too. Me too. I am going to zoom in on this over here because I am seeing some interesting flow patterns that I'd like you to see as well. So we're just going to... The chartreuse is your thanks, huh? Nice. I want to zoom in over here because there are some flow patterns that are happening in this small one. Oh, thanks, Phoenix. I appreciate that. Thanks for letting me know. Let's put a few drops in here. So you can see the red developing. It's easier to see the flow patterns when I add the base. So just so you know, the different colors that you see are indicating whether the solution is acidic or basic. So you can see mostly it's like a pH of 6 right now. Got a little bit of neutral in there as well. So the reason why you see different colors is because it takes time for the solution to homogenize. I'm going to go ahead and add a few more drops of acid. Here we go, right here, right in the center. And that's going to change our pH probably to 3. All right. And then what we're going to do, let's go one more drop here. Okay. This is Joker in a parallel world. Andrew, tell me a little bit more about what you mean. Okay, I'm going to add drops of base now. We should be able to... What happens if I add some milk or salt? That's an interesting question. Unfortunately, I don't have any milk or salt with me. Look at those flow patterns. And we get a little rainbow action. It's beautiful. So, you know, we're seeing a wide variety of pH in there. McDaints, come on, man, let's keep it clean. What I'm using is 20% by weight hydrochloric acid and 20% by weight sodium hydroxide. The indicator, McDaints, what I'm using is universal indicator. So you can purchase that online almost anywhere. All right, let's add some. Now, it's a little tougher to see the acid. So I'm going to add 2 drops of acid here. Yeah, it's a little tough to see the red that develops from the acid. I'm going to try something just a little bit different this time. I'm gonna just change the lighting a bit to see if I can't see the acid a little bit better. Well, we got a nice pH 8. That's kind of rare. pH 9 and 8. Those are kind of rare to get. And there it goes right back to 10. Let me another 2 drops. It's pretty. What I'm doing there, Specco, is I am adding either acid or base to some universal indicator. Do I have any weak acids on hand? Asked McDaints. I do. The issue with that, McDaints, is if I start adding acetic acid and then I add base to that, I'm going to have a buffered system. And then the color changes aren't as interesting. Do I have some... I don't think I have vinegar downstairs here in my basement anyways, but that's definitely something to try later. Thank you there, Specco. Okay, let's do a couple drops of base up here. Appreciate it. 1 drop. You might notice that the material does tend to stay centered. Oh, there's the rainbow. Come on, baby. I'm loving the rainbow when it happens. It's just so pretty. So pretty. All right, we can back off and look at them both. I don't know what you like better. Do you like looking at both of them, or do you like looking at one up close? Y'all let me know, and I'm happy to do either. I'm also happy to try a slightly different experiment where I add acid to milk of magnesia, which is a strong base. I agree, Chartreuse. You got it, Lone Wolf. So, Specco, what's going on here, bud? What's going on is I am either adding acid. Right now I'm adding acid to the flask on the left. And you'll notice when I add acid, the color shifts to more red, and we go from neutral to acidic. Which that should make sense, right? I'm adding acid, so it's going to get more acidic. And you'll notice over here, this is the pH scale. So as you add acid, the indicator is just a system of dyes in here that tells you the pH. And as I add the acid, the pH drops. Now, if I add base, so right now I'm going to add a drop of base over here on the left. The base will mix with the acid and neutralize it, which is going to pull this to a more neutral pH. You can see we've gone from maybe a pH of 3. Down here at the bottom, maybe it's a pH of 4. You like that up close, huh, Corey? So yeah, we went from a pH of 3 to a pH of 4 when I added a drop of base. So we've gone more neutral. I'm going to add another drop of base. And if I completely neutralize the acid, we'll get to a pH of 7. Folks are saying, Corey said he likes it up close, so I'm going to go up close over here. And, you know, it takes time for the acid and base to fully mix, especially because in this flask I'm using a very small stir bar. But you see, I've added like 2 or 3 drops of base, and we've gone from pH 3 to pH 6, which is more neutral. All right, so I'm going to add 1 more drop of base. Let's see if we neutralize the system. What's going on, Syed? Thank you there, Willow. I appreciate it. That definitely is me. I'm 100% nerd, Willow. 100%. That's totally... Look at that flow, man. That was some cool flow action. And yeah, I've neutralized... Well, it's you know, it's greenish yellow, so we're almost at neutral. Add 2 drops, says San, and you'll sub. You got it. Here we go. Up here at the top. 1, 2 drops. You got it, Sans. And it's all right if you don't. You don't need to sub. You can ask me to do stuff, and it's fine. I don't. Thank you there, Alistor. I appreciate that. Appreciate that a lot. Hey, thanks, Sans. I appreciate that. Thank you there, Corey. Sorry, Chartreuse, I missed the question. Okay, now we're at a pH of 10, all right? Very basic. Now I'm going to start adding acid. All right, the acid I'm adding is hydrochloric acid. It's the same acid that's found in your stomach. It's just that this is a lot... Hello there, fruit. This is a lot more concentrated than what's in your stomach. You're right, Ohio man. I can't make it black. You're right. So the crazy says add 3 drops. Here we go. I'm going to add 3 drops up here. You can see me. 3 drops. 1, 2, 3 of hydrochloric acid. Let's see what happens. You got 2 drops next, Brian. So we were at pH 10. Yokai, I'm going to tell you here in a second, okay? The indicator, Isla, is a universal indicator. It is beautiful, man. Thank you there, the crazy. All right, Sonny. We're going to go 2 more drops here in a second. So there's a lot of questions coming through. Here, let me add the 2 drops first. So the question is, why does it change from the bottom first? EHX, I am adding 20% by weight hydrochloric acid and 20% by weight sodium hydroxide. Thank you there, Jackson. Love the name. That's the name of one of my sums. Thank you there, Sonny. Okay, the question is, why does it change color from the bottom? Let me try to explain this. So I am adding, if you check, I'm always adding to the middle of this vortex here. All right? The middle of the vortex. And just like, you know, a vortex in a hurricane, right? Like this guy over here, there's a big vortex over here. Here, I'll watch. I'll add a drop over here. In it goes, right? You can see there's like some material caught in the middle. Yeah? I can do the same thing over here. All right? Just like the eye of a hurricane is low pressure, the eye of this vortex is low pressure as well. And material tends to stay concentrated. You can see it. I just added base, and it's staying concentrated here. The base stays concentrated in the center of the vortex. Now, of course, it gets pulled down to the bottom. Here, let's watch this again. I'm going to add another drop here. You can see it stays in the center of the vortex in the low-pressure region. And it gets pulled down. It hits the bottom. And when it hits the bottom, it gets spread out. And when it gets spread out, that's when you see the color change. So what's spinning on the bottom is a little magnetic stir. Hot dog, the reagents, I call this the rainbow tornado. It's, you know, gosh, that's beautiful. What a beautiful flow pattern. And what I'm using, it's simply water, to which I have added some universal indicator. Universal indicator, you can purchase this online. And then I just add either drops of 20% by weight hydrochloric acid or 20% by weight sodium hydroxide. Chartreuse, you know it. I am a physical chemist, so indeed I study chemistry from a physicist perspective. Thank you there, Amir. I appreciate that. Lopo asks, can we drink that? Anyone who's been on my live before, why don't you answer that for Lopo? Can we drink this solution? All right, the crazy, 5 drops. Here we go. I'm going to add 5 drops of base. Here we go. Check it out up here at the top. 1, 2, 3, 4, 5. And it looks like nighttime has overtaken. So I'm turning up the speed over here. So the reason why I wouldn't want to drink this is because one of the dyes, it's a system of dyes. There's like 4 different dyes in here, and one of them's used to be the main ingredient in X-Lax. So yeah, I mean, I could drink it if I wanted to, but it might end alive in about 15 minutes. Let's add, up here at the top, you can see I'm going to start adding some hydrochloric acid. 1, 2, 3, 4, 5. Let's see what happens. See if we get the rainbow going on. Hunter, I don't do astronomy. Okay, well, it looks like, man, all the acid got consumed. Let's add a little more. 1, 2, 3, 4, 5 more drops of the acid, and there is a slight fiery rainbow. I agree, Brian. Sorry if I'm not saying that name right. It sounds like Brian. What is hydrochloric acid? Is it salt or something different? It's something different. Let me show you this. So hydrochloric acid is a hydrogen atom bonded to a chlorine atom. So it's like this. HCl, okay? That's sort of the chemical formula for hydrochloric acid. And the base I'm adding is sodium hydroxide. So this is the chemical formula for sodium is Na. Its Latin name is natrium, and this is hydroxide. Now check out, when you add this acid and this base, the H from the hydrochloric acid, that's what acids do. They donate H plus ions, reacts with the OH from the hydroxide. HOH makes water. So we're going to get some water. And what's left over is sodium and chloride. Sodium chloride, it's salt. So when you react these two very nasty caustic materials together, you end up with salt and water. You get salt water. You get salt water. That's what's going on in the reaction. Oh, I knocked my thing down. What type of acid is in the stomach? It's hydrochloric acid. Here, let's add a little, let's add some acid to this. Hydrochloric, a couple drops. 1, 2, 3. What's universal indicator? Asks Harsh. Universal indicator, at least the one that I'm using, there's different recipes, but the universal indicator that I use is comprised of thymol blue. Thymol blue shows these colors at different pH values. It also has some methyl red in it, which shows these colors. It has some bromothymol blue, which shows these colors. And then there's the one that's the laxative, phenolphthalein. And when you add all them up, you get these different colors at different pH values. Oh, Deanimator did some titrations yesterday. I'm loving it. Can you put it on your skin? I wouldn't recommend it. You know, I'm not real sure what the hazards and toxicity of all those different indicators are. Denier, sorry if I'm saying your name wrong. The hydrochloric acid I'm using is quite concentrated, is 20% by weight, which is why I'm wearing gloves. But the leftover solution is salt water. If it was perfectly balanced, yeah, you could drink the salt water. The issue is the indicators in there. And I don't know entirely the toxicity and the hazards of the indicators. I do know that phenolphthalein is a laxative. This is an exothermic reaction. I think it runs at 57 kilojoules per mole. 10 drops, says Sans. Yes, just keep making the rainbow, says 6. Do I have a curved screen lens to put in front of it? EHX? I do not. I am interested to hear why you think I should do that. Where do I get the acid from? I get it from the hardware store. Hunter wants to be an astrophysicist. Yes, pH can be below 1 or higher than 14. It's just that the indicator system that I'm doing, once it hits 3 and below, it stays red. And once it hits 10 and above, it stays violet. Hey, Shimura, welcome. Shimura's a member on the channel. Appreciate that. I would not put it on your skin. Come on, man. Hydrochloric acid can be used as a laxative. I have no idea. I have no clue. Hot Dog says, Tommy, I want your opinion. This Saturday and the next 2 I have to do open day to some 12-year-olds I like to do at our high school or chem school. Do I have any cool reactions? Well, it depends on what you have. Yeah, I got plenty of very cool reactions. Eduardo, I did not need to use a respirator. Sorry, I'm a little behind on the comments, y'all. Edge of the tornado seems so fast because I see. I'm trying to catch up with the comments. I appreciate it. I gotta get up to speed. What happens if we pour both acid and base at the same time? Asked Bala. Let's find out. Come on, let's find out. Up here at the top, let's do a drop of, let's see. On the left, I'm adding base. On the right, I'm adding acid. On the left, I'm adding base. On the right, I'm adding acid. On the left, I'm adding base. On the right, I'm adding acid. And we are getting an absolutely beautiful effect. Thank you for the suggestion. I'm making a Birkeland dye reactor for the production of nitric acid. I need to plug my PTFE tubing with something that will resist nitric acid. I'm not the right guy to ask. Thank you, Bala. I don't have any zinc sulfite. What's my favorite element? Come on, everybody. Drop your favorite element in the chat. You're welcome, Bala. My favorite element happens to be hydrogen. It is the first element that was formed after the Big Bang, and you need hydrogen to make all the other elements. Lithium, says Marusha. Excuse me, Mayuresh. Okay, Aditya wants me to explain what's going on in this reaction. Lithium, says Harry. Yes, MV, pH, negative pH is real. We got a magnesium. Yes, you can do this with cabbage water. Sam likes element 92, which is uranium. Someone likes phosphorus, that's Shimori. Chartreuse still likes lithium. Lithium is pretty cool. Hassan says the favorite's fire. So he's back in the in Greek times there. Uranium, carbon, the most versatile element. I don't have any sodium with me. Moscovium, I love it. Oxygen, I don't have any sodium. Silicon, somebody loves tungsten, somebody likes zinc, someone likes cesium. I have heard of liquid helium. I've actually used it in some experiments for my PhD. Somebody likes gold. Maddie likes zinc. Don't Hit Me likes copper. Josie likes, oh, Josie's just saying hi. I thought Josie was, my brain was seeing H-I. Americium, I saw you. I saw americium. Platinum, scandium. So long, the animator. Silver, says Maddie. Palladium, because 0 s electrons. Are you serious? Come on, man. Palladium has s electrons. It has to. Oganesson. Lithium and cobalt. Nice. Hopefully we can get away from those, right? Francium, plutonium. Sans likes copper. Daenerys likes xenon. There's Shimori says, bunch of people on Team Zinc. Arsenic says philanthropist. Daenerys says xenon. Josie says copper. Bismuth says Sam. And the comments are coming through pretty quick. I apologize. I'm trying to get to them. What would the God particle be considered? I thought that was the Higgs boson. I thought, don't hit me. I think the Higgs boson is what people call the God particle. Your favorite sodium, hydrogen, bromide. Nah, bro. Iridium, poison. Water and carbon dioxide, floss. I'm loving some CO2 as well. What an interesting compound. Californium, technetium, and tungsten, because they have cool name origins, says Flynn. Arsenic, says Fanbat. I do have some sulfuric acid in my basement. I do. Daenerys. I tend not to use it. Okay, so there were some folks. Lawrencium, rutherfordium, hydrogen peroxide, a compound. Do I have any H9O? Never heard of it, Sans. I don't think that thing exists. H9O. I do have borax. Americium, says Mad Spurs. How's the tornado thing in the beaker? Okay, I'm going to stop reading the elements for a bit because there's a couple questions coming through. The tornado is, if you watch down here, I'm going to turn off this dial right down here. And when I do that, there's a little magnet in here that stops spinning. That magnet will spin like it is over here in this flask. Over here in this flask. There you go. This one's spinning. These things are like a fan blade inside it that's magnetic. And when that fan spins, it spins that little magnet. So here, I'll turn it back on. You can drink it if you want, but it's going to ruin your afternoon. Yeah, we can do another reaction if you want. If you guys are getting bored of this one, we can do the vibranium. I'm loving it. Vibranium. Can I make? I can't do that. I'm not a synthetic chemist. Sam, I'd be happy to do anything with Now Red. It'd be an honor to meet him. It really would. I get it a lot. I get a lot of people saying, "Hey, this guy wants to be Now Red," and my usually I just answer, "Hey, look, man, we old school chemistry teachers. We've been doing pretty much. I'm not gonna say all of them, but we've been doing most of the experiment that Now Red does. We've been doing those for years." Absolutely, I'm loving Now Red's channel, Syed. Put 10. All right, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 10 drops for you. Can I try putting paper in it? Brett's rule has been disproved. Never heard of Brett's rule. Can I make sodium? Oh my God, I'm so sorry. This is coming through a little too fast for me. Don't worry about Deniers suggesting a reaction. There's only so many things I have in here in my basement that I could use. I agree, Sam. Pretty colors. Thank you, Madge Spears. H2O. Add uranium. I don't have any, man. I don't have any uranium in my basement. I agree, Nado. They are pretty. Don't hit me. Could this experiment be sold as a safe lava lamp? You know, I can't envision how to do it, but I think it probably could be done. It's an engineering problem. Thank you there, Chartreuse. Einsteinium somebody likes. Radium. What's the most dangerous element in my basement? Probably radium. Excuse me, radon. You know, everyone's got a little bit of radon in their basement. But, you know, it's just coming through naturally. All right, let's do another reaction. Deniers has been very patient. I am not a synthetic chemist, so I am not somebody that makes stuff. I am somebody who likes to understand chemistry. I'm a physical chemist. Different branches of chemistry. All right, let's try this one. Here we go. I got a fresh flask here with a fresh... Hey, Brian. Hello. Say hello to your brother. Cosmic likes some Einsteinium. Adida, I am a physical chemist. Bala, I would not drink this in the neutral state because one of the dyes in there is a laxative. Hello. You're welcome, Brian. Can I make elephant toothpaste? I can, Amira. I can do that. Check out my check out some of my videos. I'm from the United States. Thoughts on organic chemistry? It's great, man. I love it. Hello, Josie. Hello, La Mita. Physical chem is pretty tough. I can't. I don't make I don't make chemicals. I study them. I try to understand them. All right, I'm pouring a little water in here. This is distilled water, okay? A little distilled water. All right. And now to the distilled water, I'm going to add some universal indicator, mechanical chemistry, electrochemistry, and physical chemistry. Action pack. I'm loving those too. Someone here from New Zealand. Yeah, here, I'll put some acid in here. We're going to put some acid in here. Someone's asking for acid. I'll just put a few drops over there. There you go. I add a few drops over there. All right, here we go. Spider from France, welcome. All right, here we go. Now I'm going to add some universal indicator. Universal indicator displays these colors at different pH values, okay? So I've put pure water in here, except it's not quite entirely pure because it has been exposed to the atmosphere. And any water that's been exposed to the atmosphere will have some carbon dioxide in it. So here we go. I'm going to add the universal indicator, which you can see is green and neutral. You see the pH scale over here. So watch what happens when I add it to this purified water that has some carbon dioxide in it. it doesn't stay green, it shifts to a yellow color, and that is because carbon dioxide, when it dissolves in water, is an acid. So we have a slightly acidic solution, and that doesn't surprise me. I see this all the time when I put universal indicator into pure water, distilled water. I get a pH of 6, and that's from the dissolved carbon dioxide that's in the water. So this is not surprising to me. Hey, someone here from Montana. I did a couple, I did some chemical work up there in Montana, Bozeman. Yep, make carbonic acid. Is it safe to drink? Sure. Distilled water is safe to drink. Yep, that's right, Andrew. Yep. Okay, now I'm to this. I'm going to add some milk of magnesia, which people take as an antacid, an anti-acid, which means it's a base. Hello from Spain. I see that. Joshua, we physical chemists, we can do a lot of different things. We're just, I'm like a generalist, okay? I'm somebody who, I know a little bit about a lot of different types of chemistry. That's the best way to describe me. That doesn't mean, you got to check the stuff I say, though. Okay, here we go. The indicator is called universal indicator. Hello, Sarah from Italy. Unobtainium, milk of magnesia. Here we go. Here we go. All right. So here we go. You got it. I'm a jack of all trades and master of none. Although there's a few things that I know quite a bit about. So here we go. In goes the milk of magnesia right here in the center. It's made of magnesium hydroxide, which is not soluble in water, but it is a little bit. So you can tell, you see that cloudy stuff? That's because it's a white solid. But a little bit of it dissolves, just a bit. And you can tell a little bit of it dissolves because the stuff that dissolves makes this basic. So we went from a pH of 6. I'm saying we're like a pH of 7 or 8 right now, maybe more like 8, okay? And that's because as the solid, a little bit of the solid dissolves, that's going to make the solution basic. And we're going to let this run for a little bit. We might get this to pH 9 if I let it run enough. I don't know. Sometimes it does, sometimes it doesn't. Hello. Gallon stand. I did some videos on gallon stand. Check them out. Philippines are here. So yeah, you can see now we've gone from like an aqua color to, well, I guess it's still aqua, but it's more like solidly pH 8. As the milk of magnesia dissolves, that pH is going to continue to get higher. Hello from Portugal. Evil Angel. Very cool. Hello, D. Elliott. Someone from Ireland. Why is it called milk? Because it looks cloudy. It may go all the way to purple. Thanks for hanging out, Chartreuse. Appreciate it. So yeah, now it's pH 9. So you can see as the milk of magnesia dissolves, someone from Germany, someone from Russia. Hello, everybody. What's the indicator? It's universal indicator. Someone from Antarctica, someone from New Zealand, someone from France, some Germans, Malawi, Vancouver Island. Hello, Evan. David from Romania. Mike from Switzerland. Amrinder from India. Thank you there, Aditya. Ayush from India. Skyad from India. Hey, look at that. We're now at pH pretty much 10, okay? Austria, Belgium, India. Patty from America. Sarah from Italy. Lewis from Kenya. Pat K, Antarctica. Danielle, Syria. Hello. Rashmid from Sierra Leone. Victor from Brazil. Someone from Slovakia. Pernikovi. Sorry, I'm not saying you right. I'm so sorry. Isn't pH 10 bad for the body? Depends what you're trying to accomplish. Curiosity from America. Jordan from Germany. Rockin' from Tucson, Arizona. I love Arizona. What a great place. Zulquarin from Pakistan. Hello, Sarah. Zach from America. I don't know much about wine fermentation. I apologize. Okay, let's check this out. I'm going to stop reading the comments just for a bit, okay? So now, we have in this flask some milk of magnesia, okay? Milk of magnesia is this stuff. Some of this stuff dissolves. I'm going to add acid to it. And the acid will react with all of this stuff that dissolves, and it will neutralize it, okay? It'll neutralize it. So here we go. Let's add a couple drops of acid. You're going to love this. Here we go. Up here at the top. You can see me adding it. Here we go. 1, 2, 3. Let's do 3 drops. See what happens. So it neutralized the milk of magnesia, and it went red because I added acid. But remember, there's still solid in here, and that, once again, as that solid milk of magnesia dissolves, it should pull the pH back high again. And I can tell there's still milk, still milk of magnesia in here because it's cloudy. And there it is. It's flashing back. Isn't that crazy? Isn't that cool? Very cool. So we can tell there's still solid milk of magnesia in here as long as it's cloudy. Look at this one over here. This is not cloudy. This doesn't have any solid material in it that can dissolve. So if I add acid to this one over here, 1, 2, 3 drops. Let's add a few more. Make sure we get it acid. That's not going to flash back. Okay? This one will. Let's add a drop. Let's go 2 drops. Here we go. 2 drops. So we're at like what? pH 7 or we're at like pH 8. Yeah? pH 8, which is basic. Here we go. 2 drops of acid. 1, 2. Let's go. No, that's enough. So the acid is in there, and very slowly the undissolved milk of magnesia will react with it. And there it goes. We're at pH 5, 6 or 7. Yeah, I am using highly concentrated acid. It's like 20% by weight. I don't have any chlorosulfonic acid with me and Dromalius. It's like, yeah, it's like a traffic light reaction. It's kind of cool. Isn't that cool? We're up to pH 8. Happy birthday, Red Duck Sister Rama. Happy birthday. Anybody else celebrating a birthday in the chat? The acid I'm using is hydrochloric acid. It's the same acid that you find in your stomach. DNA extraction. You can just use Joshua. I think you use that with just strawberries and a little bit of isopropyl alcohol and detergent. Hello, Louise from Brazil. Is my favorite metal technetium as Ayush? Ooh, that's interesting. I don't know what my favorite metal is. Yeah, I do. My favorite metal is metallic hydrogen. It exists in the core of Jupiter and Saturn. That's kind of cool, ain't it? Okay, we're back to like a pH 9. You can still see we got some undissolved solid in here. So let me add some acid. Here we go. Mike, tell me what Caro's acid is again. I've forgotten that. Here we go. Up here at the top, let's add 2 drops of acid. You can see it pH shifts down to 3, but because there's undissolved milk of magnesia, that pH should rise. We're at 4. You can see it. We're at 5. We're at 6. We're at 7. Do I have a favorite scientist? Sarah, I do. I love Richard Feynman. Sulfuric acid with hydrogen peroxide, Mike. We call that piranha solution. I've made a couple videos on piranha solution. So long, Adidia. Thanks for hanging out. Thanks for hanging out. Yeah, we're up to pH 8. So it sounds like my wife is home. She's been working all day. I need to go make her some dinner. I'm going to add a couple drops of acid up here while I'm talking. 1, 2, 3. So live's going to end pretty soon. Voice changer. Come on, man. I appreciate that. Just sent me a gift. Very nice. Thank you. Favorite science YouTuber as D. Elliott? That's a great question. Who do I most often watch on YouTube Science? I don't really know. You ever see Nerd Rage? Nerd Rage pretty cool. Yeah, Mike, I've made that. We call it piranha solution. Thank you there, Rock and Rock Out. Appreciate it. Thank you, Terry. Appreciate the follow. Yeah, we're going to be ending the live here pretty soon. What I kind of do right at the end of the live, I flip the hot squeeze. What we're doing is I'm adding acid or base to universal indicator. Thank you there, Syad. I don't use that, Desmond. I'm going to flip the camera around and I talk to folks for the end, okay? So I do that for about 5 minutes at the end. So thank you, voice changer. I appreciate it a lot. It does, Buzz. So I'm going to flip the camera around here. I'm just giving you a warning. You're going to see an old man in his basement, okay? Just if you don't want to see that thing, then now's your time to leave. All right? Here we go. Flipping her around. Haas, I do not stream every day. I usually stream on the weekends. Hello, Syed. Sarah, probably on a Friday, Saturday, or Sunday. Cheeto, the pH indicator didn't go from 1 to 14 because 3 and below it stays red, 10 and above it stays violet. You like my readers, huh? Hello, Jordan. I love doing fun chemistry things, yes. Lyric, yes, I have shown the piranha solution in acid. Have a nice day, Spider. Thanks there, Jacob. Appreciate that. Love the name. One of my sons is named Jacob. I'd turn that off. Haas, yeah. I mean, I do this reaction a lot. People just tend to like it. It's kind of pretty. People just kind of watch and we chat a little bit. Thank you there, Terry. Law Matea, I usually stream on the weekends. So that's going to be like Friday, Saturday, Sunday. The difference between uranium and plutonium is a number of protons in the nucleus. Yeah, Lewis, I've done a couple videos with alkali metals and water. Sure, Sarah. You just let me know. Send me an email at tommytechnetium@gmail.com. What is technetium? It's element number 43 on the periodic table. Thanks, Syed. Hang out. Tell me, what's your question there, Kevin? You got it, Sarah. Look forward to hearing from you. Haas, I have done that. I've done a few videos with reactive metals like sodium, lithium, potassium. Kevin. Sorry, Boris Aid. Maybe next time. Thanks, Patty. Well, I appreciate y'all hanging out with me. And it's a lot of fun. It is a lot of fun. Thank you for being part of the live. Thanks for enjoying some of the beauty of science. Thanks there, Gallius. Thanks, Helvidios. Yeah, just has the next stream will probably be like Friday, Saturday, or Sunday. Yeah, so just thanks for hanging out. Thanks for checking out some of the beauty of science, and as you go about your day and as you're doing whatever it is that you're doing, just pay a little attention to the world around you, man. Hey, voice changer, come on, man. Thank you. I appreciate that. You keep sending me money, man. You're making me embarrassed. Thank you. Oh, man. Thanks, Marvel. So we'll see you around and be looking for that beauty in the world around you, and just take a little time and wonder. And thanks for being here and doing some wondering with me. Sarah, send me an email and we'll catch you next time. All right, I'm gonna go see my wife.